Hi, I'm Rodrigo Jamaban. My team member is Brian Jose Escalante Martinez. So I'm going to show how to build spatial vectors in GeoGebra. For that, I'm going to explain how to build cylindric spatial vectors and spheric spatial vectors. Unfortunately, I don't have Office programs. For that, I can show the presentation. I can explain the presentation and how to build it in GeoGebra, but I'm going to explain how to build it in GeoGebra. My team member Ryan Martinez made the presentation in GeoGebra. To can build it in GeoGebra, we need to use GeoGebra. For that, we going to write GeoGebra in the navigator. We choose the first one and we start the calculator. For that, I have a Cartesian plane with x-axis and y-axis. Then we are going to use that and choose the calculator 3D. But what's the difference of that? Then I have the x-axis, y-axis and z-axis. That is the plumb axis. And to can build that, I'm going to explain how to build a cylindric vectors. For that, this special cylindric vectors just use x and y. For example, I have x squared, but the vectors it will be in square. X squared plus 2y squared. And finally, we need to use the result of that, but imagine after that I will use the number 3. It's equal to 3. For that I have the spatial vectors, so you can look that the x and y. For example, I have the x is the green, this is the x and this is the y and this is the z. The blue is the z. This is the z vector. But what happens if I play number and final we have this vector? So we have the but what is the difference with another spatial vector? For example, the cylindric vector just have x and y, but it have never a z. But what happens if I write a z? For example, we have add I don't know, a z square equal 3. For z square equal 3, we have a sphere. You can look, this is the sphere. You can look that. What? This is the difference. The main difference of that, it's not important of that. So we have another geometric figure that we will look in 2 unit plus z square. You can use the components of this sphere. For example, the coordinate origin is in 0, 0. X equals 0, y equals 0, and z equals 0 because it's asymmetrical. But if we will write another number in x, it will change. But it isn't a sphere, it is another geometrical figure. For example, we write that and I have it look like an egg. For that we have an egg term, but if we will write the same number instead, 2. The equation is 2x squared plus 2y squared plus 2z squared equal 3. It equal a sphere. A sphere. But with that is the sphere. The main difference in a cylindric and a sphere is that the cylindric has a two equations, the x and y, and the result, and the sphere it just have the x and y. You can look the difference, so we will write the first example, x squared plus y squared is equal to 3. We have the sphere, the cylindric, or 2. It's smaller than the sphere. The sphere is smaller than this cylindric, or 1. If we will use the 1, the cylindric is smaller than the sphere, but you can build using this is the main idea of our presentation, how to build a sphere and a cylindric coordinate using GeoGebra, for that in spatial parts. It has a different application in our world. But what are the cylindrical coordinates? The cylindrical coordinates are defined as a set of two coordinates that are used to locate a point in the cylindric parts. And sphere coordinates are a three-dimensional coordinate system used to describe the point of a point in the space using three values: a radial distance, an elevation angle, and a symmetrical angle. And for that's the main difference. Thanks for look our presentation and look my explaining. And that's it for mine. I'm Jorge Jonavan, and that's it. My team member is Brian Jose Grande Martinez. Thank you so much.